Hello everyone, good evening. So here we shall solve from question number 22 onwards in exercise 1. So here it is told to show that the angles of an equilateral triangle are 60 degrees each. So here we will write the given. In the given we will draw one triangle which is an equilateral triangle. Equilateral means all the sides are equal, and we have to show that all the three angles are also equal, which is 60 degrees each. So here you will write given that triangle ABC is equilateral. Triangle ABC is equilateral. It means that is AB equal to BC is equal to CA is equal to AC. And we have to prove that angle A equal to angle B equal to angle C, that is equal to 60 degree. Means each of the angles is equal to 60 degree. And the proof will be right that triangle ABC, AB equal to AC is equal to BC, which is given. So therefore, I can say that angle A will be equal to angle B. Since why? The reason is that since the angles opposite to the equal sides, angles opposite to the equal sides of a triangle are also equal. Angles opposite to the equal sides of a triangle are also equal. And similarly, you can see that angle B will be equal to angle C. Same, the reason is same, since the angles opposite to the equal sides, which are AB and AC. Here it is AB and C. And similarly, here angle A and angle C means they're opposite to the equal sides, which is BA and BC. Sorry, angle A and angle B, it means they are opposite to angles CA and CB or BC. CA and BC of a triangle are also equal. Or I can say triangle ABC are also equal. So here also I will tell the angles opposite to the equal sides AB and AC of triangle ABC are also equal. So therefore I can say angle A that is equal to angle B equal to angle C. And we also know that the sum of the three angles is also equal to 180 degrees. So angle B plus angle A plus angle B plus angle C is 180 degrees, which is the angle sum property of a triangle. Angle sum property of a triangle. So therefore I can say this angle B is also angle A, angle C is also angle A. So I will say angle A plus angle A plus angle A, that is equal to 180 degree. I can say that 3 times angle A, that is equal to 180 degree. Therefore angle A, that is equal to 180 degree divided by 3, which is equal to 60 degree. So therefore I can say angle A is equal to angle B equal to angle C, which is equal to 60 degree. Thanks, please. Then here it is told AB is a line segment. P and Q are points on opposite sides of AB. such that each of them is equidistant from the points A and B. So that the line PQ is the perpendicular bisector of AB. So here, so first we'll write what is given. So it is given that P and Q are two points which are opposite to the line segment AB, such that they are equidistant from it. They are equidistant from AB, which means, that is, I can write that is AP equal to VP and QA equal to QB. We have to prove that PQ is the perpendicular bisector of A. That means PQ is perpendicular bisector of the line segment H that we have to prove. So we will write the proof. So the proof is that we say that in triangle APQ and triangle BPQ, can say that AP equal to BP and QA equal to QB. And PQ is the common side. PQ is the common side. So therefore, I can say that triangle APQ is congruent to triangle BPQ. How? By SSS, by side rule of congruency. This rule of congruency. So therefore, I can say that angle AQP is equal to angle PQP, or I can also say angle AQC that is equal to angle BQC. This is by CBSE. So now, therefore, I can say therefore now in triangle A, so the figure was like this. This was Q, this was A, so this is P. This was B, this was A, this was B. So now here, these two are equal, it is told this is also equal. And we have shown that these two angles are also equal by CT. That AQC equal to, so this is C. AQC that is equal to BQC. So now I will tell in triangle AQC, triangle BQC, angle AQC that is equal to angle BQC, which is proved earlier, or I can say proved above. And CQ is the common side. CQ is the common side, and AQ equal to BQ, which is given. So therefore, I can say triangle AQC that is also congruent to triangle BQC. How? By side angle side. Since why we have taken two sides and the included angle. So by SAS rule of congruency, these two triangles are congruent. So I can say that. I can say that AC equal to BC, which is CPCT, and also angle ACQ that is equal to angle BCQ, which is also CPCT. Now we can also see that angle ACQ plus angle BCQ, that is equal to 180 degree. Since why? It is forming a linear pair. So therefore, I can say that ACQ and BCQ is same. So I can say twice of angle ACQ, that is equal to 180 degrees. So I can say angle ACQ is also equal to 90 degree. It means angle ACQ equal to angle BCQ, that is equal to 90 degree. So each of these two angles is 90 degrees. So hence I can say that CQ is perpendicular to AB. Or I can say PQ is also perpendicular to AB. And we have also showed that AC is equal to BC. So hence we can say that hence PQ is the perpendicular bisector, since it is perpendicular to AB also and it bisects the line AB also. So I will say PQ is the perpendicular bisector of AB. So hence proved. Hence proved. And here we can say, here it is told that P is a point which is equidistant from two lines L and M intersecting at the point A, so that the line AB bisects the angle in between them. So it is given that given that that line L and M intersect each other at the point A, and P is a point equidistant. P is a point which is equidistant from the lines L and M, from L and M. And we have to prove that AP bisects the angle between L and M. Bisect the angle between L and M. That we have to prove. So here we can do some construction. Construction is that we can draw perpendiculars from the point P on the lines L and M, that is PC and PB. So we can say PB perpendicular to the line L and PC perpendicular to the line M are drawn. Then we have to prove. The proof is, now I will say that in triangle PAB and triangle PAC, angle so P is equidistant from L and M. So hence I can say, so PB perpendicular to L and PC perpendicular to M are drawn. So hence I can say, so PB will be equal to PC, since why it is given already that P is equidistant from L and M. So simply I can say that PB will be equal to PC. Now here in triangle PAB and PAC, angle PBA that is equal to angle PCA that is equal to 90 degree, which is according to the construction. According to construction. And AP is common side. AP is the common side. And PB that is equal to PC. And PB is equal to PC. Okay. And PB is equal to PC, which is also given. So here I can see that we have, so these in these two right angled triangles, the hypotenuse AP is common and the two sides are equal. So by RHS rule, by using right angle hypotenuse side rule of congruency, we can say that AP PAB will be congruent to PAC. So therefore we can say triangle PAB is congruent to triangle PAC. PAB is congruent to triangle PAC now by RHS. The RHS rule of congruency. RHS rule of congruency. And so I can say that, so angle PAB that is equal to angle PAC. So I can say angle PAB that is equal to angle PAC now by CPCT. So hence we can say that hence the angle A is bisected by AP, or I can say hence AP bisects angle A, or I can say AC bisects angle BAC, or the angle in between L and M. So hence proved. Then in question number 25 it is told triangle ABC and triangle DBC are two isosceles triangles on the same base BC, and vertices A and D are on the same side of BC. If AD is extended to intersect BC at P, so that triangle ABD is congruent to triangle ACD. C and D are on the same base of BC. If AD is extended to intersect BC at P. So now we have to write what is given. So given is triangle ABC and triangle DBC are two isosceles triangles on the same base. And vertices A and D are on the same side, of BC, such that obviously AB equal to AC and DB is equal to DC. DB is equal to DC. And then AD is extended to intersect BC at P. Then we will try to prove. So what we have to prove? We have to prove the first part is triangle ABD is congruent to triangle ACD. The second part is we have to prove triangle ABE is congruent to ABP is congruent to triangle ACP. Third part is AP bisects both angle A and angle D. And fourth subpart is AP is the perpendicular bisector of BC. Is perpendicular bisector of BC. So now here, first we will draw the figure here. First we will write, okay, so the proof will be, we will write that in triangle ABD and triangle ADC, you can see that angle you can see that AB equal to AC, which is given, and also BD is equal to CD, which is also given, and AD is the common side. AD is the common side. So hence I can say that these two triangles are congruent by side, since all the three sides are equal. So by SSS rule of congruency, these two triangles are congruent. So therefore, simply I will say, therefore, triangle ABD is congruent to triangle ACD. Right. So the triangle we can draw again here. So is actually like this. It's AD and C. ADBC. These two are same. These two are also same. So ABD is congruent to triangle ACD by SSS rule of congruency. So therefore, so I can say that angle BAD, that is equal to angle CAD by CBCT. And also we can see that angle ABD, that is equal to angle ACD by CBCT. And this is extended to P also. So now we have to show for, so here it means we have proved part 1. The subpart 1 has been proved. Then ABP is congruent to ACP. Now I will say, now in triangle ADP and triangle ACP, angle BAP, that is equal to angle CAP. Since we have shown BAD is equal to CAD, so it means BAP also will be equal to CAP. So I will say it is proved above, or I can say proved earlier. And we can say AP is the common side. So AP equal to AP, I will write. P is the common side. And AB equal to AC. This given. So therefore I can say triangle ABP is congruent to triangle ACP. How? By side angle side, by SAS rule of congruency. By SAS rule of congruency. SAS rule of congruency. And then you can say AP is perpendicular bisector of BC. So here the AP bisects so hence here we have shown that BAD is equal to CAD. So here only we can, so therefore simply we can write, so therefore angle P, so I can say that AP bisects angle A. P bisects angle A. Since angle BAD is equal to angle CAD, which has been proved earlier only. And also we can say also in triangle BDP and triangle EDP, you can see that angle, so from here only, let's say this is not required, simply here only I can say that an angle ADB that will be equal to angle ADC by CT. So from here only I can say that angle BDP, which is equal to 180 degree minus, and since why this angle is 180 degree minus angle ADB, that, and angle CTP also will be equal to angle 180 degree minus angle ADC. Since why they are forming a linear pair. So now since these two are equal, so I can say that, so therefore I can say angle BDP also will be equal to angle CDP. Since we have already shown that, since 180 degree minus angle ADB, that would be also equal to 180 degree minus angle ADC, since we have already shown that these two angles are same. So I can say that AB bisects angle D also. So hence the third part is proof that AB bisects angle A as well as angle D. So AB is the perpendicular bisector. So now from here, so now therefore we can also say that BP is equal to CP and angle BPD, that is equal to angle CPD. Since by CPCT, since CPCT, since we have shown that triangle ABP is congruent to triangle ACP. And also I can see that angle BPD plus angle CPD, that is equal to CPD, that is equal to 180 degree, since it is forming a linear pair. So I can say each of BPD equal to angle CPD, that is equal to 180 degree by 2, that is 90 degree. So hence we can say that hence AP is the perpendicular bisector. AP is the perpendicular bisector of BC. So hence proof. Hence proof. So hope that all of you have understood the solutions of all these questions till question number 25. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. So thank you everyone.